So now we want to evaluate this integral, and I'm going to teach you how to solve this particular question. So solution goes like this. First of all, it is a very good practice that we'll assume this integral to be equal to I. So let me write that I is equal to integral 0 to infinity e raised to minus x cube. Now this square root of x is in denominator, so I'll take that in the numerator. So square root of x is equal to, look, square root of x is nothing but x raised to half. Okay, and if that goes in numerator, that will become x raised to negative half dx. Okay, now that's a simplified version of the given integral. Now once you get this, this is x cube. Now once you get this integral in this form, okay, you should know this basic formula. Okay, if your integral is of this type, where you have limits going from 0 to infinity, e raised to minus x, x raised to n minus 1 dx, this is a standard integral, and the answer of this integral is always gamma n. Okay, so what we'll try to do is the integral that we have here, now this integral over here, we'll try to get it in exact same format. Now I just want you to observe that we want this term to be e to the minus x, whereas we have got e to the minus x cube. So this x cube has to go. So the step over here is going to be substitute. Now remember one point, that whenever you come across a question of integration, it can be always solved by method of substitution. So we are going to do the substitution. Let's put x cube is equal to t. Okay, that substitution will take care and will make it e to the minus t. So let me write down the integral I after the substitution will become whatever the limits are. We have to change the limits also, e to the minus t. And now can you see that this is perfectly matching with this type? Okay, so e to the minus t is very similar to the e to the minus x. Okay, so that is one change, which is this is very good. But then look, when we have the initial integral I over here, this is all in the terms of x. The variable was x, and we've decided to substitute x cube as equal to t. So the next integral will be all in terms of t. So we have to change everything. We have to find out dx equivalent in terms of t. So now what we do here is let's find a cube root of this. Okay, so if I do cube root of this, it is going to be x equal to t raised to 1 by 3. I took a cube root on both sides. And now I'll differentiate this. So if I differentiate, it will become dx is equal to, this is the derivative of t raised to 1 by 3 is going to be 1 by 3 t raised to 1 by 3 minus 1, 1 by 3 minus 1 dt. Okay, so I'll write dx is equal to, this is 1 by 3 t raised to, now let's simplify this, 3 2s are 3 1s are 3, that's minus 2 by 3 dt. So now that's the replacement I got for dx. Also we have to change the limits, right? So let's change the limit. The limits of x were from 0 to infinity. Okay, we have to find equivalent limits for t also. Now how do we do that? Look, the relation of x and t is given here, right? This is the relation. Now what you do is put x is equal to 0. When you put x equal to 0, the t will be 0. Okay, and when you put x is equal to infinity, infinity cube is infinity, so t will be infinity in that case. So t will go from 0 to infinity. All right, so now these new limits are of t, and they're going from 0 to infinity. Okay, now you see this is x raised to negative half, so just substitute the value. You see that x is equal to t raised to 1 by 3. Now this value of x as t raised to 1 by 3, I'll replace here. So I'll get this as t raised to 1 by 3, and then the power here is negative half. Okay, I'll also substitute for dx, and if you see the dx value is over here, that is 1 by 3 t raised to minus 2 by 3 dt. All right, so let me just like make some differentiation here. Okay, this is the working of the problem, and now if you see this entire integral was in terms of x, okay, which is reduced to the entire integral in terms of t. Okay, now after you do that simplification, we will have to simplify and solve this question. Now see how it goes. I'll write this down as I. Okay, see it like this. I is equal to integral t will go from 0 to infinity, and I can take this 1 by 3 out. So this is 1 by 3 constant. I'll write it over here. That's 1/3. And then this is e raised to minus t, that I took this term. And then this will be t raised to 1 by 3 raised to minus 1 by 6. It's going to be minus t raised to 1 by 3 raised to minus 1 by 2 will be t raised to minus 1 by 6, this term here. And then I'll merge this also with this. So I'm sure you know that t raised to a into t raised to b can be written as t raised to a plus b. So I can just add the power. Now this becomes t raised to minus 1 by 6, and this is minus 2 by 3, and I'll add them up. So t raised to minus 1 by 6 minus 2 by 3. That's the power for t, and then dt. So I took all the terms, right? E raised to minus t is over here. Then t raised to minus 1 by 6 and minus 2 by 3, I took it here. And dt is here, and 1/3 is kept outside. So now let me write it in a nicer way. This is going to be 1 by 3 integration 0 to infinity e raised to minus t, and this is t raised to minus 1 by 6 minus 2 by 3. We have to simplify this. So I'll multiply by 2, this becomes 6. Multiply by 2, this becomes 4. There is a minus sign common, and then I'll write down this as 6. And then this is minus 1 minus 4. That's minus, it's 1 and 4, right? That's 5 by 6 dt. All right, that's the simplified version. Now what we have to do is the integral that we have got over here, okay, we have to make it match to this standard form, okay, and there has to be an absolute match. What I mean is the integral limits are from 0 to infinity. Okay, they are from 0 to infinity, so this is working fine. Then do you have e raised to minus t? E raised to minus is x. That is working fine. So this is also matching. Now what you want to do is you have the variable t, okay, and you want it to be n minus 1. Now there is a standard procedure to do this. You simply add 1 and subtract 1. So this becomes your n. Can you imagine? This is t raised to n minus 1, and if you compare it with this, it is going to be, this is going to be your n. All right. And now if you see, the answer of this integral is called as gamma n. So I'll write this down as gamma n, and the answer is like this. The integral I is going to be equal to gamma n. N is our this term, right? So it is 6 minus 5 plus 6 is going to be 1. It's 1 by 6. So the answer is gamma 1 by 6. Okay. And 1 by 6, gamma 1 by 6 can't be simplified more. And this is going to be your final answer to this question. I hope you followed this.